What's up, team? I'm going to work through two problems in this video, both of them utilizing Desmus. So page 201, numbers 5 and 16. This is going to be an orthocenter problem first and then a centroid problem second. The orthocenter problem, we need to do a little work on the board first before we dive into the Desmus. The centroid one, we can spend our whole time on Desmus. So let's dive into this part first. Again, page 201, number 5. We're asked to find the orthocenter with this triangle that has vertices -4, -9, 5, 6, and -2, 0. So I've set myself up with a little bit of work on the board already. Well, I haven't actually done any work yet. I just set myself up so I don't have to write all this stuff out beforehand. First, I'm going to find the slope of DE. I'm going to find the opposite reciprocal, which is the perpendicular slope. I'm going to write down my x1 and my y1, which is the points that this line needs to go through. It's going to be the vertex S, so it's going to be the pretty much the letter that's not here. This one needs to go through vertex F, this one needs to go through vertex D, and this one needs to go through vertex E. That's just what altitudes are. They go from one vertex to the opposite side, or they're a line that's perpendicular to the opposite side that goes through a given vertex. Okay, I've said too much. Let's just get into this. DE, that's these 2 points. We need to find the slope. Delta y over delta x. I'm not going to show all of my work here. If you're struggling with slope formula, that's fine. We have a whole video lesson for that, so make sure to review. So the change in y, that's going to be 6 minus -9, which is 15, over the change in x, 5 minus -4, that is 9er. This can be reduced ever so slightly. It looks like 3 goes into both these, so it's going to end up being 5/3. That's the slope of line DE, or side DE. Now we're going to flip it upside down and negate it to get our perpendicular slope. That's -3/5. Now this thing needs to go through the opposite vertex. That's vertex F. So for my x1, y1, I have x1 and y1, -2 and 0. Now I'm going to put these into point slope form. Here's my point, here's my slope. So it's going to be y minus y1 equals m times x minus x1. There we go. And of course, we can simplify this. Y equals -3/5 times x plus 2. And you can type it in just like this in the Desmus. It'll understand what you're saying. So I'm just going to leave it like that. Next one. Side EF has a slope. Let's go the other way. I'm going to do 6 minus 0. That's 6. 5 minus -2. That's 7. Perpendicular to that is -7/6. This is side EF, so it needs to go through vertex D. My x1 is -4. My y1 is -9. Let's put it in point slope form. Y minus -9 equals -7/6 times x minus -4. Clean that up just a little bit. I'm going to leave it in this form, and this is what I'm going to plug into Desmus in a minute. Third one, DF has a slope. Let's do -9 minus 0. So on top we'll have -9, and then -4 minus -2. That's kind of funky. So it's -4 plus 2, which ends up being -2. Simplifying this, we get 9/2. It's positive, so the perpendicular slope will be -2/9. This is side DF. It needs to go through vertex E. So x1 is 5, y1 is 6. Point slope form, y minus 6 equals -2/9 times x minus 5. Okay, these three equations, make sure to have these captured. In a moment, you're going to see these 3 lines. Well, we're going to set things up on Desmus, and we'll be utilizing these 3 lines. Okay, that's the first part of finding orthocenters. Okay, hey, I'm down here now. So we're on Desmus, page 201, number 5, says find the orthocenter of these 3 points. So here's what I did. I typed in the coordinates of these 3 points. -4, -9 came from point D, vertex D. 5, 6 came from vertex E, negative 2, 0 came from vertex F, and then I did something a little sneaky. I also typed in vertex D a second time. Reason being is because watch what happens if I take it out. Oh, well, the whole thing just goes away. That's not what I wanted to happen. Okay, that's what I wanted to show you. It'll connect the dots between, the first point and the second point and the third point, but I wanted to connect back to that first point again. So I'm going to type this in how I had it a moment ago. Now, some folks are struggling to get the lines in there. I get that. It's kind of tricky. So see this little black thing here with the lines on it? If you click on it, just click and let go, it makes it go away. Well, I want it there. So I clicked on it again, brought it back. If I click on it, but I hold my clicker down, I don't let go, if I hold it for a second or two, this little menu comes up. And this little menu, I can change the color of things. I can change if I want the points to be hollow. I can change if I want them X's. I like them just regular. Don't worry about this next piece. I did turn the label on, however. I wanted to see the vertices. And down here, you can choose, put the lines in. So you can turn them off, turn them on. You can make them dashed. You can make them dotted. You can make them thicker or whatever. You can have some fun with this if you choose to. I just want solid lines, and I want my original triangle to be black. Okay, so again, if you click on this and hold it down, you're presented with more options. These next three boxes, what I have here is I typed in the equations that we just found a few minutes ago, and by clicking right here, it's going to show the line. So click right here. It's the color blue, so we see some blue here. This is going through our vertex, and it's perpendicular to the opposite side. And you can see the line goes on forever and ever. That's great. Okay, the second one, when I click on it, this one's green, and you can see it goes to the vertex, and it's perpendicular to its opposite side. Now, this one looks funny because it doesn't go through the triangle. But remember, it just needs to be perpendicular to this side here where my mouse is going. And so if I were to continue this line all the way through to the green line and keep it going, we're saying that this line that I'm sort of trying to trace here would be perpendicular to our green line. So that's why it's an altitude. The third one, again, we found this equation earlier, and I just typed it in, and that's the purple one. Again, this is perpendicular to the opposite side, right where my mouse is going. If I keep it going up, try to be perfectly straight, it's going to be perpendicular to this line that I'm tracing. So our three lines, they meet, gosh, where do they meet? Let's go find it. Looks like they meet right here. Here's the point of concurrency. So this is this point right here where they meet at negative, it looks like negative 22, positive 12 is our, what's the word? Orthocenter. It looks like this is our orthocenter. I'm noticing that this point here that we found, though I believe it's true, I like the work that we did, it's different than what's in the answer key, and I sincerely apologize for that. The book answer key was incorrect on this one. Good thing we solved it. Good thing we found out where the actual orthocenter is. Okay, so this process that we just completed, I'm okay if you solve it this way. If you use Desmos on the quiz itself, this is the only time I'm going to be okay with it, but I am going to be okay with it this time. So feel free to watch the video again if you need a hand or need a reminder or whatnot. The next half of this video, I'm going to be just on Desmos finding the centroid of another triangle. Okay, page 201, number 16. We're trying to find the centroid of triangle ABC. A is at the points 8, 10, B is at 1, negative 10, C is at 3, 3. I plotted these 3 points. I put the first one in again, connect the dots just like last time. Now what we're going to do is we need to find all 3 midpoints of these 3 sides. And as we go, I'm going to find a midpoint, and I'm going to connect the dots and find the median in the same step. So you probably could be doing this on paper. I'm going to talk through the midpoint formula. If you're struggling with the midpoint formula piece, please go look it up. It's something we've studied this semester. There are videos about it, and you should have the formula in front of you as you do this. Okay, so this first one, I'm going to connect the dots between 8, 10, which is right up here. It's red now, and the opposite midpoint. So that's the midpoint between these 2 points. The way to find that is we're going to take our x's, add them together, divide by 2. 3 plus 1 is 4. 4 divided by 2 is 2. So that's our new x-coordinate. And our y-coordinate, we're going to do the same thing with the y's. 3 plus a negative 10, well, that's minus 7. So minus 7 over 2. negative 7 divided by 2. Close the parentheses, and boom, I have a midpoint in here. Now I'm going to do the long click over here, and I'm just going to click lines. Boom, median's in. We can make it dotted if we want, just to show it's not part of the actual triangle, it's the median. Okay, same thing with my next point, 1 comma negative 10. This is vertex B, and we're going to figure out the midpoint between A and C. So vertex B is down here, so we need the midpoint of between 3, 3 and 8, 10. Same process. 3 plus 8 is 11, so I'm going to type in 11, divide that business by 2. If you want to write 5.5, that's fine. Desmos will interpret it the same way. Now let's look at the y's. 3 plus 10 is 13. So I'm going to type in 13 over 2. Again, 6.5 works there if you wanted to write 6.5. You can see my points already popped up. Here's the midpoint. It's at 5.5, 6.5. I'm going to do a long click, toggle on the lines, and again, I'm going to make it dotted. So here we go. We have our second line. Third one, let's see, 3, 3 is where the vertex is, and the midpoint on the opposite side. So that's the midpoint between A and B. 1 plus 8 is 9. So my x-coordinate is going to be half of 9, 9 over 2. And the y-coordinate, negative 10 plus 10, well, that's 0. Half of 0, still 0. There we go. Midpoint, it pops up right here in green. Long click, throw the line in there, make it dotted for funsies. We can see that they all intersect at the same spot. Let's zoom in and find out what spot this is. It looks like it's right here. X value of 4, we can see that. And a Y value over here, we can see it's positive 1. So 4, 1 is where I believe this centroid is. Just to confirm, I'm going to plot the point 4, 1 and label it centroid. And it popped up right where our 3 medians intersected. So this is how you can use Desmos to find a centroid. You're also welcome to do it algebraically. If you want to find the 3 midpoints, create an equation of a line that connects a vertex to the opposite midpoint, you can totally do that. And you have to do that 3 times, solve it algebraically like we did in class for the ortho center. It's difficult, it's challenging, but it's not impossible. It's fine. You can do it. It just takes a little bit more time, and you're going to get the same response as you did here. On the quiz, full disclosure, for both of these, I'm going to supply you with 3 vertices. I'm going to supply you with the graph, and I'd say go find the ortho center and go find the centroid. If you use Desmos, great. Now, if you did use Desmos and you end up with a picture that looks like this, what I need you to do at that point is to take a screenshot of this whole page, your picture plus all the stuff over here on the left, and attach that to the quiz when you turn it in. So just attach it on Google Classroom, because I'll want to see all of your hard work. Okay, that's all for now. If you have questions, please let me know. We're reviewing in class next week, so come ready to ask some questions. All right, I believe in you.